What is the integral of x dx? X squared over 2, right? What is the integral of the x? Okay. What is the integral of u du?
The same thing as first over here.
You see the u and du are the same? So that means it's the same thing here, just different letter. So it's going to be u squared over 2 plus c. What is the integral of du?
Same.
That means it's just u plus c. What is the integral of x du? Can you do it? No, you cannot do it. They have different variable, different derivative. So the difference of u and the x, you cannot do anything. Actually a lot of people I saw you try to do this one to be x squared over 2. You cannot do it. You can only do this when they are the same letter right here. Make sense? Like x and dx. Then you can take the integral. But if they're not the same, you cannot take the integral. Okay? You cannot take the integral like this. Alright? That's what I saw very popular on the quiz. What else? Oh, trying to be careful on writing. It can cost you an almanac when you do the previous one question. Are they the same? No, completely different. Okay, so don't write too fast, and you make this kind of a mistake. And also this, what is this? If you keep like this to do the whole work, the change is you're gonna make a lot of mistakes on the sign and on the number. What is this actually equal to? It's just negative e to the x, right? So that's how you're gonna write it. Also, is this and this different? Oh, completely different, right? This one is multiplication. You multiply them, but this one, if you wrote like this, without parentheses, it's going to be a subtraction. So, even though you know it now, but when you do a test, you see this. Along the way, you start from here, you minus, and then the whole thing is going to be wrong, even though you know how to do it. So start from a small thing like this, okay? Don't underestimate it. This can cost you a lot. It can make you like the whole thing wrong. When you do multiple choice, one thing wrong, everything wrong. They're not going to give you a partial credit, okay? So be careful on writing as well. Yeah? Okay. So by plan, today we're going to do 5E, repeated IBP. So let me give you, today I'm going to do on board, because I want to do try to get the recording to see how it's working. Okay. Example 1. It's the same thing, integration by part. Okay, same thing with integration by part. Let's warm up. Okay, let's warm up. Last time. In case you want to review the integration by part, let's do some last time. How do you do this one? E to x. Yeah. You want to do user? Or you want to do iteration by part? Why you want to do iteration by part? The two functions, but you sub also two functions. Okay, one by one. Okay, Valerie. It's more complex. Okay, Shirley. LIATE. Okay, you see the LIATE here. That's right. Who else? Yeah. Yeah. Isabel. Exactly. That's the sign. You can only do the use substitution when you think that when you take the derivative of one of them, you will get the other one, so that you can cancel out. Yeah. For example, like this on a quiz. The very first question. The very first question is this. X4 e to. A lot of you I saw that you saw doing this with the iteration by part, because you saw the e, which is true. But look at this one. If you take the derivative of this, what is it equal to? 5x4, right? Do you see x4 and x4?
Yes.
So if you see one of them is the derivative of the other one, then that means you're going to do u sub. Remember, u sub is simpler and easier than iteration by part. Okay? Whatever you can do with u sub, do with u sub. Don't do iteration by part. Only when you cannot do with u sub, then you're going to start iteration by part. Okay? I'm going to fix it. Okay, maybe we can just do number 1 u with u. The question number 1 is this. So I'm taking this one, I have 5x4 dx. That means dx equal to du over 5x4, right? I'm going to plug it in here. So this is equal to x4. Let's write x4 because I don't know what is x4 now. E to what? E to the u. Du of dx. Dx becomes du over 5x4. Do you see something cancel out? Right? x4 cancel out. So I still have 1 over 5. du. Do we need to have any chain rule here? Is there any chain rule? No, because this is EU, but also DU. Same letter, good to go. Okay? What is the integral of EU, DU? Just EU. Can you keep this one as the answer? No, you need to replace by the x again, because I didn't ask you about the u, they asked about the x. Now look at the x, u equal to 2 plus x5. So e 2 plus x5 plus c. Oh, don't forget plus c. Okay? A lot of you messed up with the number 5 because you did not be careful. You wasn't be careful with the constant. You want to talk about number 5? You want to talk about number 5? Who did number 5 correctly? Who got 3 points on the number 5? Only 1, yeah. It's okay. Let's talk about it. All right, number 5. LIATE. What's the SL stand for? I inverse. So sample. Give me some sample inverse. Sine inverse of sine of cosine. A. Algebraic. Give me some sample. X squared, x5, x4. This is algebraic. x4. This is algebraic, the polynomial. Okay. T. Trig. Sine, cosine, and last one. The least priority. Exponential. This is exponential. So by the order, which one is more priority? The sine, right? Because sine and trig are both exponential. This is exponential. And then this is the trig. So by priority, so this is the one we want to do u, v, the order. Okay? Because this is higher priority. So we're going to let u equal to sine x. And then dv equal to e to the 2x. It's not hard. This problem is not hard. But a lot of you mess up with the constant, which I told you to always put the constant in the front. So if you didn't put it on the front, you're going to mess up. Okay? Now u is sine x, then what is the du? Cosine x dx. dv is e to the 2x. What is d? V equal to e to the 2x times 1 over 2, right? Because now you're going to take integral, the chain rule, you're going to divide. So I divide it by 2. The derivative of 2x is 2. So I divide it, not multiply. Multiply is for when you take a derivative. Okay? Again, the derivative of this is 2 e to x because you multiply by the chain rule. But when you take the integral, you need to divide it. So I divide it by 2. So that's good? Now the I method I told you is how I always do this. So I know that, oh, this multiply by this, u times v. So the formula iteration by part is u times v minus v du. Okay? But just memorize the I, the one I told you. So sine x times e to the 2x over 2 What else? Minus integral of e to the 2x over 2 cosine x dx. Yeah? So what's good? Now if you see the 1/2, just put them to the front. Don't so that you can just take care of everything without a number. Because when you put in a number together to the interaction by part, the chance is you're gonna make a mistake if you don't be careful. I always show you the way, the same thing in hand. I always show you the way that's gonna make less chance to make a mistake. Okay? So put the number in the front. And now you just need to take care of this one. Same thing, exponential and trig, which one is more prioritized? Trig. So u equal to cosine. And dv equal to e to 2x again. Yeah? So what's it good? See? Okay. du equal to negative sine x dx, and v equal to, again, same thing, over 2. Same thing, you're gonna do the I thing. But this one, just do this part, but you need to copy yet. Okay? Don't copy yet. That's what I do. But if you could, you can copy, but I'm not gonna copy yet. I'll just take care of this one, this part. Okay? Just take care of this one. So I'm gonna have cosine x e to the 2x over 2 minus integral of negative sine x times e to the 2x over 2 dx. Yeah? You see negative to negative? It's become positive. Okay? Okay, I'm gonna write one more. Cosine x. So you understand what's going on. Plus sine x e to the 2x. Now, I see another 1/2. I think I'm gonna put it on the front again. Always when you see the number, to put in the front. Okay? Now this one, don't try to do it again. Why? Do you see the loop? Because this is exactly the same as the original problem. If you do it again, you're gonna get the same thing again, the same thing again, and you're gonna do until you're 80 years old. If you don't do it, infinity, not like at 80 years old you're gonna done it. So this is the trick we did in class. You have original problem here. Now copy everything. Minus 1/2, minus 1/2. The integral here become this whole thing. So I need to have the what? The whole thing here, the whole integral become this already. Before I write this, I need to have the parentheses. A lot of you actually don't have the parentheses, and you forgot to multiply 1/2 with this 1/2. You need to have parentheses because the whole integral here become this already. So now this part, we're going to use different color. Cosine, let's do this. Cosine x e to the 2x over 2 plus 1/2 integral sine x e to the 2x dx. It's hard to say now. Let me write it. Okay, I'm going to write this one over here. You're going to have sine x e to x over 2 minus 1/2 upper parenthesis cosine x e to 2x over 2 plus 1/2 integral of sine e to 2x sine x e to the e 2x over no over 2 dx. So what's good? Do I lost anyone yet? No? Right? Is it following, right? Okay, cool. Now that's the answer. That's basically the answer. You get 80% done. Okay, yeah.
Wait, so when you do it twice, you always have to have like the parentheses.
You always need to have parentheses because the whole thing here becomes this. So if you don't have parentheses, what happened? What happened? That means you only multiply 1/2 to this one.
Oh.
You won't remember to multiply 1/2 to 1/2 here.
Oh, so like
So you have 1/4. So you need your parentheses. Parentheses make a big difference. Okay? A lot of you didn't have the parentheses. That's why you all, only one person got it right perfectly. Okay? Now, because of parentheses, I'm gonna distribute everything. So I'm gonna have what? Sine x, sine e to the 2x over 2 minus 1/2 cosine x. Oh, you see 1/2 over here? So that actually become 1 4. 1 4 cosine e to 2x plus, oh, minus negative, so negative 1/2 times 1/2 is negative 1 4. Negative 1 4. Negative 1 4 sine x e to x. It's very easy to make a mistake, so you need to be careful line by line. So that's good. Now what we're gonna do next? We learned in class. We did it in class. What we're gonna do next? The original problem. The original problem is this, right? After we done everything, we got this. And when you take a look, you see that this one right here and this one right here actually the same, right? So you're gonna move to the same side. Similar when you learn how to solve this. X plus 2 equals 7 minus x. How are you gonna solve x? You're gonna x both sides, right? So you're gonna have 2x equal to 5, and then you divide by 2 to get x, right? Same thing here. This one what you want to find. This is also what you want to find. I'm gonna move this one over here. So I'm gonna do what? I'm gonna add 1 4 integral of sine x e to 2x dx. Add 1 4 e to 2x sine x dx. It's good. 1 plus 1 4 is 2. 1 plus 1 4 is 5 4, right? 5 over 4 integral of e to the 2x sine x dx equal to this whole thing here. So sine x e to x 1/2. You can put 1/2 too. So 1/2 minus 1 4 cosine x e to 2x. So that's good?
Where
Yes.
did you get the 1 to add it to 1 4?
1 is the original problem. This one equal to whole thing here. So like this is the original problem you want to find.
Yeah, I got that part.
Yeah?
Where did the 1 come from? Is that from the original?
There's no number here that means invisible one. Right? So 1 plus 1 4 is 5 4. Any question? Ask me any question. Right question?
So
Which one? Yeah.
Why do we still have the integral on the e to the 2x sine x?
This one?
No. On the
This one?
Yeah.
Oh, we still have this. We still have this. They are the same. We don't know how to solve them because after we solve them, we get a loop, right? But from here, we can put them together. The goal is you want to solve what is this equal to. I have another one here, so I'm going to combine them together first. And now I have 5 over 4 equal to this. How do I get rid of 5 over 4 then? You divide by 5 over 4, or you multiply both sides by 4 over 5, right? So I'm going to multiply everything by 4 over 5. Everything by 4 over 5. So 5, 4, 4, 5 is gone. Now, this is what I'm looking for. And that actually equal to, now distribute 4 over 5 here. 4 over 5 times 1/2 is 2 over 5, right? 4 and 2 they cancel out. Simplify. What is 1 over 4 times 4 over 5? 4 and 4 cancel out. You have 1 over 4 times 4 over 5. 4 and 4 cancel out. You have 1 over 5. Okay? So minus 1 over 5 cosine x e to 2x, and that is your answer. Yeah? Let's see. Oh, plus C, that's right. See, be careful and see. Yeah.
I decided the 1 over 4, how does someone where did you get the 5 over 4?
5 over 4?
Yeah, how'd you get that?
Oh, 5 over 4 because I have negative 1 over 4. This, I'm going to add 1 over 4 both sides because these are the same. I'm going to combine that term. And then I have invisible 1. 1 plus 1 over 4 is 5 over 4. So 1, invisible 1. 1 plus 1 over 4 is 5 over 4. Yeah, like this. Like this. Okay, how about this? Similarly, we have something like this. X equal to 7 minus 1 over 4x. How do you combine x together? you're gonna add 1 over 4x, right? Add 1 over 4x. So this becomes 5 over 4x equal to 7. Yeah? This is what we're looking for. This is what you're looking for.
And then you just multiply by the opposite.
And then I'm going to multiply both sides by 4 over 5 to cancel them out. Cancel them out. So I have x equal to 5. Okay? Any question? Yeah? Is there any other question you want me to show you? On quiz? 2, 3, 4? 4? Are we done with this? We have recording though, the morning. Yeah? Can I erase it? Yes? Can I erase it? Yes. The reason I can review the quiz because today is easy. Today is just a one method you need to learn. The next 2 lessons is going to be hard. The trick substitution and trick integral. There's a kind of formula you need to memorize. It's kind of tricky.
Right?
Okay. Let me check, make sure they Alright, okay, number 4. When you see this, do you think you're gonna do integration by part? Do you see any exponential?
Wait, no. I thought you said, do you see any use? So.
Do you see any exponential? Like e to anything? Do you see any log? Do you see any like inverse? Do you see any trick? So this one cannot do integration by part. Now you know for sure they're gonna do u sub, right? But what you gonna let equal to u? That's the question. This one is similar to one we did in class though. If you review it, you study right the night before. They're actually equal. So it's square root of u plus 3. Oh, x plus 3. A lot of you actually had this one. But from here, you don't know where to start. You kind of stuck here. So let's do it. If u is this, what is the u? 1 over 2 square root of x plus 3 dx. Do you see this one is also u? Do you see that? It's okay if you don't see that. dx it will be equal to 2 square root x plus 3 times du. So far so good? Yeah? Yes or no?
Yeah.
Okay.
Oh, yeah. Okay.
Any questions? Just stop me, right?
Take the derivative of square root 1 over 2 square root of x and then just plug in x for x.
Alright. Now, plugging in everything. The original problem we have x squared plus 2. This square root become u. dx become 2 times, but this is equal to what? This is actually the u. You say something? U, right? So actually here becomes u.
Why did he say yes? Like,
Do you see u and u cancel out? Yeah?
oh, that was the whole thing. I only did the inside.
Now, a lot of you actually got to here. But then after this, you're gonna write you wrote x cubed over 3 plus 2x. Is that correct?
Mister, how did you know which one to use as you?
It's just a sample. We did. We learned this type. When you see the square root, it's easier to let the square root to be the u. It's just from the experience. Right? You do it. You see this type. You know it. That's why math is like muscle memory. The more homework you do it, the more you can recognize what type and what you're gonna do. Okay. Because you try this, you can try. You can try let u equal to x squared plus 2. You will think it's gonna. You will see it's gonna be more complicated and it's stuck. Yeah. This is one of the examples we did in class though. Very similar. So what's good here? A lot you go to this step and then you get me x integral x squared equal to x cubed over 3. Is it correct though? Yeah.
Why do you use parentheses?
Why parentheses?
I think this one.
If I don't have parentheses, it's gonna look like integral only for this, not for the two.
No.
Yeah, so parentheses very important. Du for the whole thing. But the question is this correct to from here to here? Irma?
Oh, well, like, I just have a different question.
Yeah, question.
Because, okay, so you went from like the dx equals up there?
Uh-huh.
There, right there?
Yeah.
Like, he went to the next part.
Uh-huh.
But, like, how did he get there?
Oh, okay, so I'll copy the original problem here. Okay, and rewrite this one.
And you haven't,
X squared plus 2 is still the same.
but you haven't put the du.
This one is this. So what's it good? dx equal to this,
Yes.
right? dx equal to 2 times this du. But what is this? Do you see that the same?
Yes.
So this actually u. So this actually equal to 2u du. So I replace dx by 2u du. This whole thing here is the dx. Yeah? Now you cancel out. Now question is this become this? Yes or no? Why not? Because this is the du. This is the x, this is the du. I just told you in the beginning, remember? The different there letter, you cannot do it. You cannot do it. You need to change this one into the whatever letter is here. If this letter is df, then you need to change this one to df. Make sense? Because this letter is du, you need to change everything to du before you can do anything else. Does it make sense? So now I need to change this one into the u, okay? So not this. How do I change here? The information I know is only this. That's the relationship between x and u. From here, do you think there's a way you can figure out what is the x squared? From the information, do you think there's a way you can figure out what is the x squared is? U equal to square root of x plus 3. Do you think from here
Oh yeah.
you can solve for me what is the x squared equal to?
Yeah.
How, Valerie?
Oh man.
Oh man, okay, that's good. That's all man.
You just need to solve for x.
Okay, how do you solve for x? Yes, how do you solve for x?
Using the
Not it.
How do you solve for x?
Don't you just do basic algebra?
Using the information we know here. How do you solve for x?
square root.
Huh? This is square root already.
Oh, I see.
You square it. You square it. I'm gonna square both sides. Okay? So now I'm gonna get rid of the square root. So now I have what? U square equal to x plus 3. Ooh, I see the x already.
And then
That's a good sign. I want x squared though. What I'm gonna do? Don't square them yet. Don't square them yet. If you square them, you're gonna have a 3. It's gonna be complicated. Move the 3. Okay? So u squared minus 3 equal to x. That's the x I want you looking for, right? But I want the x squared. So I'm gonna do what? I'm gonna square both sides. So x squared equal to what? U squared minus 3 squared. Yeah? So this equal to what?
Instead of square rooting it?
This equal to, I'll copy everything first. X squared equal to u squared minus 3 everything square. Right? Plus 2 du.
Do you square it because we're looking for
Now is it easy now? Actually it's very easy. Just expand it the square and then that's the basic integral you're gonna do. I'm gonna write over here so you can see it. I'm gonna continue over here, okay? Right, what next?
Now do we take the integral?
You can. You actually can. But if you take integral right now, you're gonna do the chain rule. You can't expand this. You can expand this one. Alright, Kayla, what next? Expand this. Expand the square. That's easier. You don't need to do a chain rule. You
But you said expanded, no?
expand it. Yeah, expand this one.
That's like, not u squared minus,
No, just you.
U square minus 3 square. How do you expand this? Him.
You just make it into like the same thing but twice, no?
Oh, you do that way? You wanna do that? You wanna do like this?
Yeah.
Okay. And then you gonna do FOIL. What is the formula? What is formula for a minus b square? A square minus 2ab plus b square. You can use in that one. Okay? Practice this way. Don't practice this way. This is wasted time. U square. Oh no, sorry. That's the same. You practice this way better. U square become U4 minus these two together multiplied by 2. So minus 3 times u square and times 2 again. That's 2ab. That means become, I just keep like this so you understand. 6, right? And then plus b square. B is 3. 3 square is 9. So that is your expanded. U4 minus 6 u square plus 9. Right? Plus 2. You still have plus 2. Du. Any questions so far? Yeah? Yeah? I'm not losing anyone yet, right? Yeah, question. Ask me.
How do you convert like the 1 over 2 square root x plus 3?
The 1 over 2 square. 1 over 2 square. Which one? Oh, this one?
Yeah, how'd you make it the other way?
From here to here or from here to here? From here to here? From here to here? Or from here to here? Here? What is the derivative of square root of x?
1 over 2.
Yeah, 1 over 2 square root of x.
But how did you make it like just 2 square root x plus 3 or 2u? How do you make it?
Or from here to here? I multiply both sides. I multiply both sides by this to isolate the dx. So I multiply both sides by 2 square root x plus 3. So that I'm gonna have, I want to isolate this one by itself. So like if you have y equal to x over 2, you multiply both sides by 2, right? So you have 2y equal to x. Same thing. So dx divided by this, I multiply both sides by this, so I have dy times this equal to this. Yeah? Okay, good. Alright, simplify this. U4 minus 6u square plus not 9, 11.
Oh, plus 2.
Okay. 2. Now, can you take the integral? Can we take the integral? Yes, because this is u and this is also du. Become u5 over minus 6 u3 over 3 plus 11 u integral of 11, right? Plus c. Now distribute everything. 2 over 5 u5 minus 6 divided by 3 is 2, right? And then 2 times 2 is 4. So 4 u cubed plus 22 u plus c. Is that your final answer?
No.
No, you need to replace back the x. What is u equal to? Square root, right? So remember u equal to square root x plus 3. That also means x plus 3 to the power, what power? 1/2. Very good. Then maybe it's just, you can't plug it in here. You can plug it in here. I just think it's look better, more professional if you write 1/2 and then you multiply 5. So 5/2. So two answers correct. One way you can write is this. 2 over 5 x plus 3 to power 5. That's correct. Okay? Minus 4 x plus 3 power 3 plus 22 square root x plus 3 plus c. That's your answer. Okay? That's your answer.
Oh, no, there's no.
How many of you got perfect score for this number 4? Raise your hand.
He doesn't have the square root.
Oh, only one,
Because
two.
he took the square root instead of putting the 1/2. That's why it just basically. Okay.
Or you can also write power like this. X over 3, 5 over 2,
Yeah.
minus 4 x plus 3, 3 over 2, plus 22, x plus 3, 1/2. So same thing.
That does look.
It does look better, right? Yeah.
But the
But
bottom.
you don't need to write the square root every time.
The bottom looks more complicated. It looks like we're smarter.
Yeah, okay, look smarter. The radar, when they look at this, they have more bias. More, oh, this is good.
Oh wait. We want to please the people.
What are your other number?
Can we do 6?
6, 7, and 8. We're gonna do again by yourself. I hope you can figure this out. Okay? Yeah.
Oh, 6, 7, and 8.
The multiple choice. The multiple choice. Do you think you can figure number 2 by yourself?
Oh, what the hell?
Do you think you can redo number 2 by yourself? Very similar to this.
Oh. Oh wait, I have one. Why am I looking away? What was this one?
How about this? Do number 2 right now. Do number 2 right now. It's a good practice.
I think
Do
so.
number 2 right now. Very similar to the number 4. Very similar. First step, u equal to, Melissa, u equal to minus. Okay, good. Labu, du equal to
1 over. What? No.
1 over 2
Square root of 2x.
why there's a 2 here?
That's the derivative. 1
Oh,
over 2
that's the
square root.
part of
Right?
the derivative. Oh, that's the derivative of square root.
That was because 1/2 is the power.
That's just from the derivative.
Okay, okay.
And then is that the correct though?
So dx.
Not yet.
Not yet.
Not yet.
You need to multiply by another 2 from the chain rule. Okay, so you have to multiply by 2. How many of you missing that 2?
Me?
Okay.
Wait, where did the 2 come from?
Okay, these 2 here come from the derivative of square root of x is 1 over 2 square root of x. So these 2 here come from the derivative. But these 2 right here is come from the chain rule inside here. You take the derivative of this one, and then you multiply it. And 2 and 2 gone. So you only have 1 over square root of 2x minus 3 dx. Okay? That means dx equal to? Now Kayla, next, dx equal to? So du equal to dx divided by this. So what is dx equal to? Just isolate the dx.
Oh, that's just
Du. Right? You multiply both sides by this. So this gone. So you have dx equal to this. And why is this actually equal to? U. This is actually the same u. So that's the good thing about square root. When you're checking the derivative, they're not gone. They just move to the bottom. So this is equal to u du. So that's good? Now let's replace everything to the original problem. Okay? I have integral of 2x. I don't know 2x now, so I just put 2x for now. This one is u. Very good. dx equal to? Dx equal to? U du. Right? So this is dx equal to u du. U du. Can I take the integral now? Can I take the integral now?
No.
No, why not? Because it is x, but it's the u.
Yeah.
I need to change the x into the u. How do I do that? Similar to number 4 we did over here, the purple one, remember? You're gonna manipulate, you're gonna do this one in a way that you can get the x by itself. How do you get x by itself? First, I want to get rid of the square root by squaring it. Okay, so u squared equal to 2x minus 3. Oh, look at this. This is the shortcut way. If you see the 2x, you can also take it 2x. You don't need to get the x by itself. You know what I mean? So instead of answering the x by itself, I saw that, oh, I need 2x, so maybe I can just hit the 2x. So I can just replace 2x by something I got from you. So 2x equal to what? 2x equal to, Steven? 2x equal to? From here, what is 2x equal to? U square plus 3. 2x equal to this. So I replace 2x by u square plus 3. So u square plus 3.
We don't divide it, mister?
Well, that's what I just said. You can get this one, and then you plug it in here, right? But then you plug it in here, you hit 2 and 2 to cancel out, right? Or you see this is 2x, this is also 2x, so I can just replace the whole 2x by this. It is the same thing though. Okay, if you want to divide, I can do divide as well. If you want to divide like this, okay, I'm gonna plug it in, okay? 2, 2x, let's rewrite them first. Oh, this is u, right? U times u du. Okay, 2. I'm gonna bring 2 to the outside. X becomes this. U square plus 3 over 2. Oh, u times u is? U square. Du. Put it in parentheses. Okay? So far so good? You see the 2 and 2 cancel out? The 2 and 2 cancel out. What are we gonna do next though?
Can we just put, since we already know what u squared is up there?
You're going to replace the u square with this? This is the u. You don't want to go back to the x. This is good already. This is everything is u in terms of the u. What next though?
Now you plug in.
What do you mean plugging in? We're not taking. You're only plugging in after you've done the integral. We're not done the integral yet.
Do you do something with
Do we do something? Do we combine the u squares?
You distribute. You distribute. So you have u square times u square is u4. U square times 3, 3u square. Right? Can you take the integral of this? No, it's very basic, right? It's very easy now. What is the integral of u4? u5 over 5. What is the integral of u square? u3 over 3. That's it, right? Plus c. And then you cancel the 3 out. Right? You're gonna pay attention on the one you're gonna lose. Yeah?
Where are we closer?
You just miss one part and you feel like you left for an hour. Because one part, if you stuck at one part, you cannot move on. So you need to pay attention here. Okay, are we good for now? Yeah? Now what is the last step?
Oh, convert it back to x.
You're going to come back to x. Okay, x equal to here. Same thing is the square root. So I think I'm gonna write like to the power 1/2. Okay? So 1/2 times 5, that's been 5/2. So we're gonna have 2x minus 3 to the power 5/2 over 5 plus 2x minus 3 to the power what power?
3 over 2.
3/2. Very good. Oh, not over 3 because we cancel out the 3 already. That's the answer. Yeah? You can learn this way too, yeah. Write this power like this better. Look better. For example, e to the x power 5. I give you 2 minutes to do this.
Whoa! Is that a C?
E.
Oh, Jesus. Scared of that.
2 minutes to do that one.
Oh my god. Okay, so this is
Okay, in 2 minutes. I don't think you can done this in 2 minutes because guess how many times you're gonna do integration by part?
5.
We're gonna do 3 times, right? 3 times, right, Jay?
Oh, so that's 3.
4 times, 4 times.
Oh, 4.
You cannot finish that in 2 minutes. But today I'm gonna show you the way to finish this one in 2 minutes. Okay? Now let's do the normal way. Let's do the normal way.
You couldn't teach this before the quiz?
Too long.
I didn't give you this one on the quiz though. No. Okay. What is the U? What is the U?
X5.
X5 because this is algebraic, right? The A go first, so X5. What is the dV?
EX.
Dx. Very good. You remember dx. Du equal to
5x.
5x4 dx. V equal to
Dx.
e to the x. Now the I thing you're gonna multiply this minus multiply this. So ex times x5 minus integral of what?
X
Yeah.
times 5x4.
5x4 times ex and then dx and put ex at the end. Okay. See the 5? Put a 5 in front.
No parentheses?
There's no plus and minus though.
Oh, okay.
Parentheses matter when you have plus and minus.
Okay.
Mister,
He just made a mistake.
mister,
Yeah?
why is there E5? Is it?
Huh?
It's
You put an
EX.
E5.
Yeah, you put E5 instead of
I put E5?
Yeah.
Yes.
Okay.
That's right. We cut.
So you're a little tired too.
I try working because we don't have enough time. Okay. Good?
Uh-huh.
What you gonna do with that with this one again?
Do it again.
You're gonna do it again. U equal to Melissa, U equal to
Oh, X.
4x.
similar to this. So you do one more time. U equal to X. Very good. dv equal to e to x. That's it. Good job. So du equal to 4x cubed and v equal to e to the x, right?
But I feel like
Did you do it
I'm
again?
gonna keep doing it.
Do it again. You're going to see integral of what? 4 times x cubed e to the x. You see this one? You're going to do it again. You keep doing it. You get do it how many times? 4 times.
Just show me the quick way, Mister.
Okay. Now here we go.
I want to what's even.
Now the new way they call tabular method.
Whoa.
Maybe I guess that's the name of the person who will make this out. Okay. I saw Yasmin know this one. That's on a lesson too. So okay, here's the way to do this in 2 minutes, maybe less than 2 minutes. You're gonna let one equal to you. If you notice, that's a pattern. Look at this. 5x4. This 5x4. You take the derivative again. You have 4x3. You multiply 4 and 5, right? If you keep doing it, all the numbers are gonna multiply. 5 times 4 times 3 times 2 times 1. So this guy, maybe, I don't know, maybe a guy or maybe I don't know why they didn't name it. Learn that that's a pattern. You actually don't need to write everything down. Do you remember long division and synthetic division?
Yeah.
Kind of similar, right?
Long division.
You don't remember? Long division, you need to write a lot, remember? But then synthetic division, what did you do? Just draw this one, chop the number, multiply, combine, remember in him? Same thing, instead of write everything down, there are 2 lines, you can just do it. One is U, one is dv.
Wait, DV?
dv.
Oh, okay.
Similar here. What is U?
X5.
X5, you got it. So I'm gonna put,
Just keep going down.
yes, let's keep going down. Yes, X5. What is dv? dx. Ready for the shortcut? You can done in 2 minutes. Let's go.
Alright, bye.
What is the derivative of x5?
1.
1.
I'm just kidding.
Let me check the consistent color. What is the derivative of 5x4?
20.
Right? What is the derivative of 20x cubed? What is the derivative of 60x squared? What is the derivative of 120x? Can we do derivative more? No, why not? Why not? It's 0. It's 0, right? What is the derivative of 120? 0. Can we do more? No, now there's nothing you can do. Yeah? You keep going 0, 0, 0, 0. Now, dv, we're going to take integral. What is the integral of e to the x? What is the integral of e to the x? So they took ex for the rest of them, right?
I don't see the truth.
Yeah? How long does it take for you to do this? 45 seconds, maybe. Or 30 seconds.
What's the truth?
Now, the step is to write out the answer. Okay? Now watch it. Are you done? I want you all pay attention here. Done? Okay, the sign. We're talking about the sign. Do you realize that they all will be minus, right? The formula is this times this minus these two together. So they all will minus. But then next, another minus become plus. And another minus become minus. So they alternated plus, minus, plus, minus. This is what you're gonna do. Plus, that's the original problem. Then minus. Then? Yeah?
Wait, mister, I thought it starts off with minus.
No, they start out with the x phi. So x phi is positive.
Oh,
Yeah?
yeah.
Right? This is x phi. If they start with the negative over here, then you're gonna start with the negative. But they alternating, they take turn. Okay? Now the order is this. What color? Oh, I do have green. This times this. This times this. This times this. This times this. This times this, and this times this. Okay? How long does it take for you for this? Maybe another 50 seconds. And then answer. Multiply them together with the sign. That's it. That's the answer. Now read together with me. X phi times e to the x, right? X phi e to the x. What next? Minus what? 5x4 e to the x. Next what? Plus 20 x cubed e to the x. What next? Minus 60x squared e to the x. What next? Plus 120 x e to the x. Last one, minus 120 e to the x.
That's their answer?
That's the answer.
What?
2 minutes, right?
Wait,
Yes.
then how do you know
Holy moly.
what we can use this for instead of like wasting our time?
When you see a lot of power like this, you know that you need to keep going like this. Like by the time you do the second again, you see the pattern already. By the time you do the integration by part again, you see that, oh, this number should repeat it. Like this one should repeat it until we get to the x0. Then you know we're gonna do tabular method. I'm gonna give you a sample. You're gonna do by yourself, maybe homework because you only have 2 minutes, right? Okay.
No.
Do this one. I'm gonna see you tomorrow.
No.
Okay. Then do this one by yourself at home. Okay. X
Write it on the paper.
x4 cosine x. Actually, do x6. Okay.
I actually don't even mind. It's kind of nice. It's kind of fun.
Homework. This is your homework. Homework.
Joshua, don't keep that test.
Can you send the picture?
Alright, hold on.